Okay, so I'm showing you a typical example where you have to use algebra. So this is like a percentage increase kind of question, but we don't have the original value. So we got nothing to compare with. So we wouldn't know our 100% whatever. So in this question, we are talking about a rectangle. So there is the length of rectangle that we are talking about, and we also talk about the width, but we are interested in the percentage change in this area. Okay, so note that the area of a rectangle is length and breadth. So if I would like to do a percentage change in area, so in my head, you will need to have a formula first. So if I would like to do a percentage change in area, I will need the new area to subtract the old area. Because if I do a subtraction, I will get the change in area. So the change in area can be either increase or decrease. But whatever is it, I will need to multiply. I will need to divide by the old area, and then I multiply by 100. The old area is the 100%. So that is the formula that I'll be applying. So right now, I don't have any dimension. I cannot have any old area. I also cannot have any new area. So I'm going to assign an original length. So I'm going to let X be the length, the original length of the rectangle. And I'm going to let Y be the original breadth, width. So in this case, it's the width of the rectangle. So with the original length and the original width, then I can get the original area. So the original area is length and breadth, which is just X times Y. So this X times Y is the 100% that we are comparing with. So after this, I'm going to get a new length because the question says that the length is increased by 25%. So you can think about, you can draw another rectangle. So that means this is the 100%. And then now the new length will be 25% more. So that means this is like 125%. So you can calculate the new length by doing a percentage algebra. So you'll be 125% over 100 times X. So you punch your calculator, that will be 1.25x. So I will get 1.25x for the new length. Or some of you might be doing like x plus 25% of x. So if you are doing x plus 25% of x, you will also be getting a 1.25x. It's up to you which one you want to do. And then I got to find the new width as well because the width is reduced by 10%. So that means, right, originally this was 100%. So now it will become a 90%. So the new width will be 90% of the original width. So I will get a 0.9y. Or you can do it this way. From the original width, you subtract a 10%. So if you do that, you will also get the same thing. So you will get 1y subtracting a 0.1y, which is 0.91. So when you get the new width and the new length, you will be able to get the new area. So with the new area, it will be 1.25x multiplied by 0.9y. So punch your calculator. It will be 1.125xy. So that will be the new area. So comparing it with the original area, which is xy, what will be the percentage change? So there is an increment in the area. So this the new area subtract the old area. The old area is xy, so that is equivalent to 1 xy, and you divide by xy. So you punch your calculator, 1.125 minus 1. That will give you 0.125 xy, and then you divide by xy, then you multiply by 100. The xy will be cancelled away. So you are left with 0.125 times 100. That becomes a 12.5% increase. So we managed to find the percentage increase without knowing the original length, original width, and the original area. You can just assign algebra for that.